Thanks a lot for having the opportunity to be here as speaker at the World-Class Connected Industry 2023 in Frankfurt. And I'm from the headquarters in Munich. As probably you see, we are in the jet engine business. The company is headquartered in Munich. We are listed here in the DAX in Germany. And we provide maintenance, repair, overhaul services. That's the after-sales business for jet engines, military and civil ones. We produce subsystems for OEM and civil and military jet engines for OEMs. So we're not an OEM. OEM means like a BMW or Mercedes or whatever in the automotive, and we're more like a tier one supplier in the jet engine business. But it's a bit different because often we are a so-called risk and revenue sharing partner. So we go to the next one, the disclaimer, I jump. So the thing is, why do I talk about the topic? In aerospace, especially in jet engine manufacturing, we have a lot of topics. We cannot be automated in a fully. So we have always, due to barriers. One is physical barriers. Physical barriers means the machine is not capable of doing the job, or it's much too expensive that they bring a machine to such a level that this can provide the service, the task. And the second one is an intelligence level. The intelligence level is, in our case, the controller or the software. The intelligence of the machine is much too low in order to perform something. And therefore, we have always to combine people and machines in order and work together. If you want to make a more systematic evaluation, there are tools in order to do that, but it's do not present tools in order to go on. So, as I mentioned already, we have a combination of strengths in humans and machines. We regard in that area humans, human beings, personnel as a valuable, genuine asset. We see them as a solution, not as a problem. And it's a very important topic within the company and in the production line in order to keep the stuff running. My experience is if you want to have a fully automated without lights out, you have to invest a lot of money and a lot of resources in order to bring that to a level. And if your personnel is capable of acting as first level support, it's much cheaper, often much more, makes much more sense. Now, as I mentioned in my presentation and the title, I talk about an existing line. It's located in our headquarters in Munich. And it's a real end-user story I'm talking about. And when we started, we had at the time a so-called U-shaped production line. And the topic was, and the task, to come to a flexible production line because we had a huge ramp-up in volume. And we didn't have the space at that time in order to go with the old concept. And on the other hand, we were heading for a huge improvement in manufacturing and productivity. And therefore, we are heading for a new type of production. At that time, Industry 4.0 was not coined. Therefore, I said a lot of Industry 4.0 elements. I'm talking about a longer history and the experience and a shared experience, what we have made in the last years about the technology. When I talk about the production system here, I mean that's the strategy, the business model of the new line. And it's, for me, it's pivotal, as I heard in earlier presentations today. But if that is not correct, you run to the wrong vision. And that vision has to be powerful in order to get the buy-in from the people and to achieve the topics. So, yeah, of course, you need a strategy in order to come from the present at that time to the new situation. It has to be coherent. Coherent means it has to fix with the capabilities of your personnel and the capabilities of your organization. Furthermore, it has several layers, areas. One is, of course, the strategic level, the functional level, and tactical level. And on the other hand, you have to have a firm understanding, so my experience, on the strategic level, what is really needed on the tactical level in order to make the right decisions. At the time we started with the line, that was present. So, but there's another very important topic, and that's the transformation. The transformation means the way you think, the way you act, and how the organization sees and regards the new topic, the new line, and it has to be a sound solution from technology, processes, and the capabilities of the human beings and the personnel and the production system. That has to be sound as like a gearbox. It has to run. If it doesn't fit together, and I say later on, if it doesn't do it, if you don't do it, you run into a problem. Okay. Now, a few words about the production system. Of course, it has several pillars according to our understanding at that time. One is, of course, the efficiency. It's made clear. If you're not efficient, you burn resources. Efficiency means, in that case, the machines run without user interaction. The users are, or the personnel is responsible for supplying the parts in that area and the tools. And we have a 24/7 capability. That's from the adaptability in order to cope with the erratic demand in that area. And the demand is very erratic. So furthermore, we have an automatic alignment. That means the machine sees, aligns the part on how it is on the machine. And a lot of other things like changeover of a datum system, rework based on CMM data, and so on. Another very topic is a robust solution. A robust solution is for me a must in order to keep this thing running. We have invested a lot in fault-tolerant systems, fault-tolerant topics. Furthermore, we did a lot in the area that we can test software in operation. And if you have 10 machines, run one machine on the new level and monitor it and to the others. Is it working? Do you have to bring it in and have to make it a reality in such an area that is possible? And that's only the probable tip of the iceberg. I'm telling it. If you go too much deeper, it take much more time for my presentation. Now, and another one was at that time, we said we want to have data and bring it to the business value. A huge fourth topic. Now, I've talked about flexible line. Whenever I talk about a flexible line, I mean a networked, physical objects networked together, have the capabilities to exchange data via the network, via the connectivity, and exchange how the real world looks like and inform each other via software platform, data platform, and that connectivity. Now, as I mentioned before, as a strategy, the strategy is for me has more dimensions. The first dimension, as I do my title, is the human dimension. If you go to a system, and as I said before, that the humans and the machines, the systems have to work together. That means the user interface has to be in such a way that they understand each other. Later, more about the topic. The second one is we increased complexity dramatically. You have to give the personnel the opportunity to cope with that, or handle that complexity. That means a lot of complexity has to be built in the system, but the interaction has to be simple and understandable. The second dimension is the machine dimension. The former machine was a normal CNC machine. That is an intelligent cell. It's a huge difference. Dump machine was a CNC machine to an intelligent cell with automatic rework, as I mentioned before, closed loop machining capability, monolithic system was replaced by a modular system, and so on. And now there's a third dimension, and very important, and already was mentioned a couple of times in former presentations. That's the system and the data architecture. If that is unsuitable or not suitable for the topic, my experience is that creates a big problem. Now, as I mentioned before, the transformation, when we started, the focus was much on the physical assets and the machine. But that is insufficient for such a line. If you go to a flexible line to Industry 4.0, you need a focus on physical and virtual assets and data especially. And on a machine and on the software, because a lot of the capability of the machine is defined via software. And the enhancement is done often by software. Therefore, that meant a change in mindset. And that has to happen. There are, from my point of view, a couple of challenges. Challenge one is to have to see that you need a different production system, as I mentioned before in the slides with the diamond. If you don't do it, you run into a problem. Second one, and it's a very hard one. I talked in during the day break. You have to make sometimes investments. You're not having a positive MPV immediately, especially in infrastructure. If you don't do it, you can go this way down. Another one is to see that you need additional things and you have to allow it to happen. Okay, what is from my point of view, there are three topics you should remember. The greatest risk here is to act with an outdated mindset. The risk comes with that outdated mindset, not from the disruption, from the change. The second one is that you see that the hard stuff is not the hard stuff. The soft stuff, also the change, maybe the topic we have to cope. Now, let's go to a bit of the interface. Now, I talk about the perspective from the human side, from the human user. What does a human user need? We invested a lot of resources to bring a lot of things into systems, automated and so on. But the core thing is the humans, the personnel has to understand the system, and the system has to understand the human user in order to operate in an efficient way in order to come forward. So the intent from the human side is give me an intuitive user interface. It's not something we talk about, it's just for fun. It's a much deeper reason. The reason here is if you have an intuitive user interface, you can slash training. Bring training more or less to a minimum or to zero. You avoid the skills gap. You avoid that people feel incompetent. You get buy-in because they say it has to that way. And what does this mean? Acceptance and resilience of the system and the new way how you work. Furthermore, we focused on enablers. And the enablers here, if you have a good user interface, is that we can rotate the personnel within the line. And they normally rotate weekly or daily, during the stations. And if we need new personnel, it's quite easy to bring them in because there's almost no lead time due to the powerful user interface. Okay. If we go to the perspective from the machine, what is the machine requirement? Said, okay, give me the topic what you want from me in such a way that I can read it and understand it. As mentioned before, we focused on RFID and on 2D matrix. We had to go both ways because RFID gives us more opportunities. But in a lot of things, if you go to heat treatment, you cannot use RFID because it gets too hot. We have to use 2D matrix. And for the non-value, for the low volume topic, we use keyboard and, of course, the selection from some topic from the menu. Now, you see a couple of machines from the line. Of course, that's standard. Machining from raw part to machine part, it's something clear. We call it the physical value engine. And now I said we implemented a new production system. And the topic was here to bring an additional value engine. That means machine data to value. We call that stuff analytics, every software tool we use in order to bring it. The interesting topic is here, we have 3 types of value streams. One is the optimization, we're using the data to optimize the physical machining. The second one is to reduce the risk, because predictive maintenance is not part of that. More when you run into a problem, why was the problem? And the database products we give, for instance, here, performance data of a tool. It goes to Rework, to the supplier. It gets the data about the tool and the performance. Now, what is the result? The result is a value production system, 2 value streams, an infrastructure layer that contains everything, and the cells are connected to both value streams and create value on both sides. Now, if we go to product data, that means if you want to machine data to value, you have to see data in the same way as you see a raw part and give them the infrastructure as a part, as a product within the company. We did that in that environment, and you have to be careful. So we had a lot of action on it, the intellectual property, because if you get the data and you know what's behind, you have to be careful. Master data means management everything around in order to keep, to define data sets, data names, and everything, what is required. It's part of the data governance. Unique identity, already heard the presentation before. And if you rely on data, you have to make sure that the data you can trust. My experience is it's much harder, or much better, to have no data than to have false data. So, mentioned already before, the tracking and tracing. You have to have a unique identity linking physical part and virtual part together and the data. In our case, we use the serial number, product number, or speaking more in a programming language, object instance. Via the RFID, it's possible to align that in a more or less an automatic way. The trustworthiness, it's much more than IT security. If you're because we are in an environment of the machines, you have to talk about safety. If you have wrong data, maybe it can ruin your machine. Of course, if you rely on data, the data has to be available when needed. And if it's not available when needed, it's the same thing if you have no raw part or no energy, it's a stop for the machining. The resilience, as mentioned before, it has to be resilient, the whole engineering you have done. Now, the 5th element, and that is whenever possible, avoid that is part of the process data. That's the privacy topic, because if you, especially in Germany, if you have personal data or that stuff, user data, you have to always be careful. So the users are normally the machines, and the user data is outside the process data, because it's always a normal data set without any connection to a human user. Now, we have a lot of tools, and we regard the data, the process data we record from different perspectives. Important perspectives are the part. Of course, you see what's going on along the machining, and the former speaker said about the huge step. And what is an important topic too is the fleet. The fleet is, in our case, an important thing if you want to test software on one machine and the rest of the fleet runs on the old one. Is it consistent? Is it running within the specification? Is everything within thresholds? Now, I go a bit deeper. There's a lot of time series data in manufacturing, and the former presentation mentioned that. And normally, your life, of course, happens in the present. And that's very important, what's going on the whole line for the shop floor personnel. Since they are not near the machine, they are more around and work in different stations. And the question here is, what happens? The leading question. And we answered this question. What do we have to do in order to answer the question? And what is the requirement of the personnel? The second one, if you go more to the past and say, okay, what has happened and why? That's always important if you have a problem, or we have a problem, to analyze. And it's important for if you more do something into the future, that you collect the high quality data for machine learning or whatever you would like to do. And the question you ask for the future is, what shall happen and what could happen? What shall happen is necessary actions in order to keep the stuff running. What could happen is more risk approach that's going on. So the next slide is about what shall happen. That's a slide from the production line. It's have to make it so that you can not read it anything, but the transparency is a very important topic, because what's going on, what is necessary, what you see here, different machining lines or the machining centers. Red means they are stopped due to no part or no tool, or green, more than 2 hours autonomy operation, and the yellow, you need something in the within 2 hours. And the red, see the red block here, that means you need a tool, and the whole stuff, you see the autonomy of the machine. And that's very important if you run an operation without personnel. If say you maybe want a 24-hour operation, you have the autonomy of each machine at least 24 hours or more. It's very important. Was very important topic for the shop floor, for the workshop. Now, mentioned before, multi-user, multi-layer, multi-dimension platform. How do you see on the data? That's the background. That's the data architecture. Multi-level because why? In our case, if you're near the device, you have to be fast. Near time or real-time computing. The compute power is low, but you have to be very fast. And if you go more to the backbone is a corporate level, you can, of course, have greater amount of data, have more capacity, but you're not near time or the real time anymore. So we do the processing on the level best suited for the topic. And now that's my experience is if you want to go to such a line, a holistic approach is very helpful, or a must. In our case, the customer demand drove the integration of the machines into the system. And it was, in our case, we call it now custom integrated, not computer integrated in that area. We use data, process data to value. That means an open data platform. In our case, all the data is not in a silo. It's available like on an internet platform. The applications have access to the data. Furthermore, we regard data as an asset. And if you want to have data-based value creation, you have to see it and organize it that way. We have built a flexible toolkit in that area. And that flexible toolkit allows one, a fast adaptability and a focus on value. And that's now the last slide. And I think we have 3 minutes or 2 minutes or 1 minute for discussion. Thanks.